Hey, welcome to Archer's Global HQ in Palo Alto, California. I'm Adam Goldstein, co-founder and co-CEO.
And I'm Brett Adcock, co-founder and co-CEO.
We are designing for the industry called urban air mobility, electric vertical takeoff and landing aircraft.
The reason why we started this company is we're seeing unprecedented traffic inside of cities every single day in every large city around the world. Millions of people are stuck in traffic. Also, we're seeing peak carbon emissions globally as a result of the transportation sector. And so what we're trying to do here is imagine a world where we can travel really freely and very sustainably. So imagine being able to travel from Manhattan to JFK, a trip that usually takes, an hour and a half in a car that we can do in under 10 minutes. Or San Francisco to San Jose, a trip that will take a few hours traveling by car or train that we can do in under 20 minutes.
You take these vehicles and you commute to work in a really easy way. But I think it also goes beyond just commuting. I think there's an opportunity here to be able to break away from the screens, to be able to get back to nature, to be able to explore your local surroundings. It's a concept that we call micro-exploration, the ability to really fly and go where you want to be untethered from the world. These vehicles can really set you free.
I want to introduce you to Mark Moore, an Archer advisor and a longtime NASA employee.
I'm Mark Moore. For 32 years, I was at NASA inventing distributed electric propulsion, which is the foundation for what all these eVTOL companies are doing now. eVTOL stands for electric vertical takeoff and landing. What's really extraordinary about them as aircraft is because of this new technology that they're using, distributed electric propulsion, they're able to achieve a level of noise that's far less than any other aircraft has ever achieved. But it's not just about noise. It's about core values in transportation, such as safety. With these eVTOL aircraft, no critical parts. So what's different now from the prior years of buildup is that all the ingredients, all the puzzle pieces are coming together and really just creates an opportunity for transportation freedom that people have never had before.
This is a big, hard world problem that we're going to solve. We're not afraid of it. We're going to tackle it head on.
Yeah, we're going to show you today Maker. It's our full-scale electric vertical takeoff and landing aircraft.
Let's go check it out and see some more.
Before we walk over and show you Maker, here on the wall behind us, we actually have the complete history or some evolution of how we got here today.
Yeah, so our blood, sweat, and tears really are on this wall, and it's really just a small part of the long journey that we've been on to design this aircraft. When we thought about it, we really wanted the customer experience to start when you first walk up to that vehicle. And you think, wow, this is actually this new form of transportation that is going to change the way people live and work. So we put a high wing on the plane so consumers could have that sense of safety as they walk up to it, and they can feel really comfortable approaching the aircraft. If you can imagine having the chance to redesign the entire airline industry, start from scratch, where would you start? That's the way we wanted to think about this from day one. We wanted to build something that really would elicit this emotional response. But there was a lot of really technical engineering decisions that have to be considered as well, because we are building an airplane, right? And the aerodynamics matter here. And so we had to build something that balanced both this consumer emotional response with these really deep technical engineering decisions. We wanted the consumer not to just see this as a mathematical product, but something that they could actually really enjoy.
All this hard work here ended up resulting in the aircraft we see over here, so why don't we go over to the lab and check out Maker.
We are super excited to show you Maker. This is it, our full-scale electric vertical takeoff and landing aircraft.
And its purpose is to serve as a certification test bed.
And for the last year and a half, we've been working closely with the FAA on our piloted 4-passenger aircraft.
This is the end product. That's the result of years of work that have come together across lots of different disciplines. Years of work in aerodynamics, working on the avionics, working on our structure, working on our flight controls. And this is the full product that you're going to see here behind us today.
We've engineered Maker to travel 60 miles. We'll be traveling at 150 miles an hour point to point in the air. Maker is also designed to fly at 2,000 feet above ground level to be virtually silent overhead.
This vehicle weighs around 3,300 pounds. So to put that in perspective, a Tesla Model X will weigh around 5,500 pounds. The Archer aircraft was built by a new type of engineer. We have to take folks that have come from experience with vertical lift, right? Traditionally in the rotorcraft space. And then we also have to marry that with engineers that have worked on fixed-wing aircraft. And then finally, we have to marry that with folks that have worked on electric vehicles that are big. And so you have this new kind of engineer that's helped build this beautiful product that you see behind us. That's a culmination of many years of experience creating this new industry around urban air mobility.
Let's walk over here a little bit. The Maker aircraft is powered by 6 independent battery packs that are behind a bulkhead behind the passenger seating. They power 12 electric motors that are spread out laterally across the wing. These motors are attached to a little over a 40-foot wingspan. The wing is designed to be as energy efficient as possible during cruise flight, and all of this was designed aerodynamically to achieve some of the highest levels of lift over drag equivalents that we see in our industry.
One of the goals was to figure out how we create an aircraft that's both efficient in the vertical form of flight and also in the cruise portion of the flight. And so we had to design the aircraft to have enough blades, to have enough disc area to allow the vehicle to take off efficiently, but also get those blades out of the way so they're not draggy in the cruise portion of the flight. So as you'll see, these motors in the front will tilt as we are reusing them in both the hover portion as well as in the cruise portion. And that's different than you'll see in the motors that are in the back. They are fixed and are only used for the hover portion of the flight.
One of the hardest engineering problems as it relates to vehicle design for electric vertical takeoff and landing aircraft is to maximize the amount of energy on board so we can increase the performance of the aircraft. One thing we did is design a fully carbon fiber composite airframe, which basically helped us to reduce the empty weight mass fraction across the vehicle to achieve really high performance with batteries that exist today. We've designed the entire interior from scratch, so let's go take a look inside.
Safety was the most critical feature that we designed for when thinking about the Archer vehicle. It was really designed so the consumer can have not only just a great experience, but also know that this vehicle is designed at the highest levels of safety standards across all of aviation. This vehicle has 0 single points of failure. And I think that's really important here to understand that there's redundancy features built all across the aircraft. There's redundancy in our motors, there's redundancy in our battery system. Travelers will not only have just such a great consumer experience, but know they can get to and from their destination safely.
At takeoff and landing, we've designed the aircraft to be 10 times quieter than a helicopter. And during cruise flight, 2,000 feet above cities, we designed the aircraft to be 100 times quieter than a helicopter, to be the lowest noise signature possible.
This is a brand new paradigm in travel. The in-flight experience, we think, is going to be an incredible one. You have a 270-degree wraparound view where you can really see, the environment that you're flying over.